Okay, x cubed minus x minus 1 equals 0. Can you solve this by factoring? Can you solve it by factoring? It's not a trick question? No. Okay, nothing we know about factoring will work. You can try P over Q if you want. It actually does not work. So what you're going to do is you're going to use your graphing calculator. So everyone, please take out your graphing calculator. I'm going to tell you how to graph. First, know how to turn it on. Turning it on is on the bottom. What you're going to do is you're going to go to y equals, which is on the top left-hand corner. So press that button. It's going to have a y1 equals. So this is where you're going to type in your equation. All your variables is stuck in this button. It says x, t, theta, n. Okay, that's your variable button. So what you're going to do is you're going to type in that cubed. Cubed is this button. This is the caret. So if you press that button, it will create a exponent. And then you're going to type in 3, so x cubed. The new calculators will just say x cubed. And then you're going to scroll over to the right, so you're not in the exponent position anymore. And then minus x minus 1. Okay? And then you're going to click either trace or graph. That will give you the graph.
Wait, can you show me where the y?
Top left. Very top left button. Oh, you have a Casio, so I don't know how to use that calculator. We're all using TI. You're going to have to check your manual. Yeah. Okay, now what are we looking for when we're solving the problem? We said it at the beginning of the class, so what are we looking for when we solve a problem? Zeros, how does it show up on the graph? X-intercept. We're looking for the x-intercept, right? So how many x-intercept does it look like it has? 1. So we have to figure out where that crosses the x, right? So what you're going to do is you're going to have the calculator calculate that for you. This is a little tricky. You're going to press the second button. Second button should be the top left, right underneath y equals. So that is either blue or yellow, depending on your calculator. When you press that button, it accesses all of the words that are in blue. So you're now going to go to the button that says trace, but because on top of trace it says calc, you're actually doing calculation. So second trace. Okay? Now you're going to basically ask your calculator, find my zeros. So you're going to go to 0. So that's the second one. So go to 0. And now it's going to go back to the graph. It's going to ask you, what is the lower bound? Or the left bound. So basically, what's on the left of your 0? Which part is the left of your 0? That's the question. So what you're going to do is you're going to scroll over. When you move your cursor, there's a little X that moves. You're going to be a little bit just to the left of the 0, and then press enter. And then you'll see a little bit of and then you'll see this little arrow that tells you, that tells the calculator, this is the left. And then, yeah? No? Yes? So you did it? Right? Like on the left, you're a little bit to the left, and then press enter. Now you have a little. Yeah. Okay, and then now you're going to scroll to the right, so you're right on top. And then click, that's the right bound, and then click enter. So basically, you're saying my 0 is stuck in between. And then it's going to ask you to guess. Just press enter again. And it's going to say x is equal to 1.324718. All right, we are on page 17. So let's look at this. Absolute value 2x minus 1 equals 6. So obviously you know how to solve this. Now another way of looking at this same thing is on the left hand side, we're basically saying when is the left equal to the right? Meaning that you can think of it as the left hand side is a function of itself, and then on the right hand side is also a function of itself. The question is, when are the two functions equal? That's, another way to think about it. So let's think about this graphically. Absolute value 2x minus 1 is a absolute value graph that has a vertex at 0.5. So this is y equals absolute value 2x minus 1. And then the graph y equals 6 is just a flat line at 6. The question is, where do they intersect? Or what x values do they intersect? So those 2 points. And so what we do is we're just trying to figure out what x values will make those two lines intersect. So that's one way to think about it. Every time you have an equation, the left-hand side can always be thought of as a function of itself, and so is the right. Another way to think of the same thing is, let's say that I subtract 6 from both sides. So absolute value 2x minus 1 minus 6 equals 0. If I do that, what two functions am I looking at to equal to each other? Huh? What? Am I not making sense? No, I am not making sense. Okay. Thank you for letting me know. Okay, so I have this equation equal to 6. So on the left, I can think of it as an equation. On the right, I can think of it as an equation, right? That part makes sense? Yes? Okay, now if who does not understand that part?
We're like all scared
to admit it? Okay. So basically, this is a function on the left, this is a function on the right. We're just saying when are they the same. Another way to think about it is I could subtract that 6 on both sides. Now I have this equal to 0. So then on the left is this function, right?
Yeah.
What is this function on the right? 0? 0 is y equals 0, right? Y equals 0 is a special line on your graph. Huh? Y equals x. So y equals 0 is a special line on your coordinate plane. X-axis. So this is the question of when does this cross the x-axis? Right? Which is why we're doing all this stuff, right? We're making it equal to 0. Why are we looking for 0? It's basically where this is crossing the x-axis. Yeah? Okay, so let's say that I graph that same graph. So we're now going to graph this graph. That is the 2x minus 1 graph, but moved down 6. Right? Oops. Sorry. It's that same red graph, but went down 6, right? Minus 6 just means move down 6. It should always cross at the same point of x. So it does not matter how you move those graphs around, it should always cross the same x points because that's where the two sides are equal. Yes, kind of. I know it's a little bit theoretical, but I have seen this kind of question on your SAT stuff before. Yes, they do try to see, do you understand what equations actually mean? So they ask you really strange questions like this. Which one is actually exactly the same? That kind of stuff. So kind of know. Yeah. For it is the, oh, sorry. You're right. The vertex is at 0.5. I should probably draw my V a little bit better. Sorry. It went down. So the vertex should line up. We're going straight down. algebraically, you've known how to solve this for a very long time. So you basically take off the absolute value, make it equal to that same number, and then take off the absolute value, but make it equal to the negative version, and then you just solve. You guys still remember this, right? Okay, so then x is equal to 7 over 2, and then x is equal to minus 5 over 2. So that means this point here is 7 over 2. This point here is negative 5 over 2. And no matter what you do, you should always get the same answer because your graph and your algebra, all that stuff have to match. Okay, let's look at this next question. This one's a little bit strange because you probably have not seen something like this. Absolute value of this quadratic equals to 7. Okay, what should we do to solve? Silence. I think someone's just waiting for someone to answer. Huh? The algebraic way. Yeah, algebraic way.
Okay, yeah, make it negative. No, I meant 7 or negative.
7 or negative 7. X squared plus 4x minus 1 equals to 7. X squared plus 4x minus 1 equals minus 7. How many answers are you supposed to get? 2 according to this, right? According to the original question. But if you do separate it, you are going to get 4 answers. Does that make sense? Because you have 2 here and you have 2 here, which means 2 of them are not going to be real. So 2 of them are actually going to be imaginary numbers. Okay, so go ahead and try to solve. All of them are unfactorable, so you have to use either completed square or quadratic equation. Let me know when you have the answers. Okay, on the left, this one's going to give you x equals negative 2 plus minus 2 root 3. On the right, x is equal to negative 2 plus minus I root 2. Okay, so we're going to talk about I today. All right, let's kind of remind you what to do with the absolute value. So first, you got to isolate the absolute value, meaning you got to get the absolute value by itself. Then you set it to positive and negative. If you do see inequality, make sure you flip the sign. To make it negative, you want to solve and then check the answer. But for these ones, usually it's very apparent what the number should be. But that's that on the absolute value. Complex numbers. Remember, complex number is any number in the form of a plus bi. And that I means what? Yeah, imaginary number. So that's the imaginary part. The I is the imaginary part. Let's do some refresher. I. People over here. What does I stand for? Yeah, square root of negative 1. People over here. What is I squared? Minus 1. That's correct. Okay, it's just a review. So let's do square root of negative 5. Square root of negative 5 is the same thing as saying square root of negative 1 times 5, because minus 5 is just minus 1 times 5. And what we can do is we can split it up to a square root of negative 1 and square root of 5. And then we said square root of negative 1 is what? I. So then this is I root 5. You can also write root 5i. It's the same. Just please don't put that I inside the square root. Some of you do that, so please be careful. Let's have you try these next two. So I will ask you for the answer. Okay, I think You guys are good. Let's start with Allison. Square root negative 16. That becomes what? Good. And then Blake, I root negative 9.
Is that negative 3?
Yes. Okay. Now let's look at some properties. Adding and subtracting. If you're adding and subtracting complex numbers, it's kind of like combining like terms. You take all the real parts and put it together. You take all the imaginary parts and then you put that together. So easy stuff. Additive identity. So a complex number plus something equals 0. So for example, 2 plus 3i. 2 plus 3i plus what is going to equal 0? Caleb, what do you think?
Negative 2 minus 3i.
Yes, so basically the opposite. When you multiply two complex numbers because they are binomial, you have to use FOIL. So that means you need to do a first, outer, inner, last. Because i's are a little bit tricky, you need to write it all out so you don't make a mistake on the negative. So first, that's going to be 2 times 5. And then 2 times negative I is negative 2i. And then plus, 15i. And then minus 3i squared. Now I do have an I squared. I squared becomes what? Negative 1. So this part here becomes a negative 1. And that negative 1 will multiply with that negative 3 and become an actual positive 3. So actually my question is 10 minus 2i plus 15i plus 3. And then combine like terms. 13 plus 13i. The reason I want you to write it all out at first is everyone messes up on the I squared. So please be careful. Don't make small mistakes like that. Next, we cannot leave a I in the denominator. So 3 over 2 plus 3i. How do I get rid of that I in the denominator? Yeah.
2 minus 3i.
Yes, we had to multiply by 2 minus 3i, but does anyone remember the name? Yes, conjugate. But there are two words, something conjugate. It's right here. Complex conjugate. We had to multiply by complex conjugate. What is complex conjugate? We change a plus bi to a minus bi, so the sign right between a and bi changes. Okay, so let's have you guys find the complex conjugate to those complex numbers. Okay, Trey, 2 plus 3i, what's the complex conjugate? Yes. Alana, negative 5 minus I. Negative 5, sorry. Negative 5 minus I, what's the complex conjugate? Negative 5 is correct, and then what's after that? Yeah, plus I. Okay, Josh, you have the tricky one. 5i minus 4. What's the complex conjugate?
Minus 5. 4 minus 5.
You got the minus 5i correct, but not the 4. So minus 4 minus 5i. Because we want to just switch the sign in between a and bi.
We can't do 5i plus 4.
5i plus 4i?
5i plus 4.
5i plus 4. Okay, so in reality, yes, it's fine.
Oh.
The whole idea is I don't want I in the denominator. So there's a lot of things you can multiply to get rid of it. So, but to kind of talk about like the actual complex conjugate, this would be the correct thing. But yes, as long as you can get rid of it, it doesn't really matter. Okay, so the complex conjugate that we need to multiply here is 2 minus 3i. Make sure you do that to top and bottom. In the numerator, it's just a distribution. So that's 6 minus 9i. In the denominator, a plus b times a minus b, you just need to remember that becomes a squared minus b squared. So we gotta do that. Please do not FOIL. We need to take some shortcut. So that's 2 squared minus 3i squared. Okay? Okay, so that is 4. What is 3i squared? Let's try McKenna. 3i squared.
9. Wouldn't it be -9?
Yes. Yeah, so it's 9i squared, but i squared becomes a -1, so -9. Now there is a negative in the front, so that becomes a plus. So plus 9. Okay, 6 minus 9i over 13. Now, is this in the a plus bi form? Kind of, but not really. In the true a plus bi form, it will be 6 over 13 minus 9 over 13i. Okay, so I'm not super picky with that, but just know that if you do want an a part and a b part to this whole thing, then you gotta split that denominator. Okay, now let's do some practice. 1, 2, 3, 4, 5. And let's see. Let's start with Aaron. Number 1. I squared. When we see I squared, we gotta change it.
Sorry, my bad. It's
Or does Eunice have it? Number 1. Okay, 9i what? Okay, let's put it in a plus bi. So square root 7 minus 7 plus 9i, and then this part is basically the real part.
No, and you have to do it that way.
Okay, Iris, number 2. 5 plus 5i? Okay. Penny, number 3. Okay. Andy, you have the hard one. Huh? 6i square root 2? No. Okay. Oh, I see. 6i square root 2. Okay, sorry, Andy, let me have you finish. 6i square root 2, and then? Minus 5 square root 2? Uh-huh. Okay, let's put it in a plus bi. So you can see that this part is the real part, and then this part is the imaginary part. So we're going to put the real part together. That is the a. The bi part, let's take the I out. And then we have a 6 root 2 plus 12. Okay, that way it's very easy to see what you have instead of just kind of really messy. Number 5, the answer is 3/5 plus 4/5 I. Okay, and then the last one we didn't really go over, but it's very easy. It's just the discriminant of your quadratic to predict whether you're going to have real solution or imaginary solution, but we went over that last year. If you forget, you could look at the textbook really quickly, but very easy stuff.